Hi, today I'm going to show you how to measure your JavaScript TypeScript performance in under 5 minutes. This is for anyone who considers themselves a beginner or intermediate JavaScript TypeScript programmer. Some of the stuff I actually mentioned is actually general advice for all software engineers. Don't need any particular tools. I happen to use GitHub, which might come in handy for some portions, but it's not a requirement. And we'll be using a project I built in the last 2 weekends or so. Hi, my name is Andrew. I'm a software engineer based in Ireland. I'd like to give a quick shout out to anyone who's watching me from the People's Republic of Cork and Honduras. They're my largest audience by far because I just happen to have lived there and have work colleagues who I used to work closely with. I started using JavaScript when it was ES6, so that's 2015. I was actually 22 years old at the time, so a lot of time have passed, and hopefully I've accrued some technical skills that I just wish to share today. So the reason why I'm making this video is because algorithm performance has been front of mind. A few years ago, just before relocating to Ireland, I had built my first open source project. I just put it out there. I didn't think much of it at the time. A few years went by, and when I came back, I just started noticing that it was gaining some popularity. At some point, it was, averaging 500,000 downloads per month, and I was super stoked about it. On the flip side, I also started receiving a lot of feedback from people actually using the project, and most of the feedback was around performance. And at the time when I wrote that project, I just was trying to solve a specific problem. Performance wasn't really something that was, front of mind when I wrote it. So I hadn't had the time to really work on it or make it better until now. Someone suggested that, this is something that's worth just pursuing, as something interesting to work on, and I took that advice. So essentially what I'm trying to build, and I'm trying to do it in public, is basically this thing I put up as open source. I'm just going to make a dedicated micro software, SaaS, software as a service, and we'll see how it goes from there. And the first thing I want to particularly tackle is basically make it as fast as possible. And for those reasons, I start looking at algorithm performance. And in general, this video is for anyone who's actually in a situation where they're trying to make something faster, know where to start. So let's take a step back. Actually, performance is a very broad subject in software engineering. It's similar to security. So there's a saying where if you're the best way to go about making something secure is security at depth. So basically, in every layer and domain of what it is that you're trying to do, you think about security, or in this case, performance, and you just try to figure out what it is that you actually need there to make it as fast as possible. Like, it could be, like, we could be talking cloud infrastructure, like if you're talking about Azure functions or AWS lambdas, there's things like cool off periods or warm, functions might take a little bit of time to start. So maybe the first request or operation takes a little bit longer. If we're talking about database queries, there's loads of things that you can do, like using the right schemas, the right type of data types, making bespoke queries, or actually just figuring out that once you've had some data, you don't need to request it again. Also, there's loads of front-end optimizations, just simply using asynchronous fetching, maybe deferring some scripts at the start of loading your page, batching DOM modifications rather than just making them individually, or when you have a really heavy operation on the client side running on your browser, you might want to put that on a worker thread rather than on the main thread. Then there's other stuff like caching. I'm pretty sure if you're been around for some time, you've definitely heard these concepts like memoization, first in, first out type cache, or expiration aware cache, Redis, local storage, using that in front end. There's plenty to talk about, but I'm just mentioning that for just giving you a very broad stroke picture that performance is just not one specific thing. Now, for the purpose of this video, we're actually going to specifically focus on and just going to zoom in on algorithm performance. Yeah. Okay. I'm going to tell you a little story that actually happened to me at a previous workplace. I built this very neat service and it was performing great, except that for some reason it was becoming slow. And at the time, the first thing I looked at is like, okay, so let's gather some data. So what is the actual business requirements? And then what is the actual projected requirements from here in 1 year, 2 years time? And from that, I kind of knew what sort of goal I was targeting towards. So I did my investigation work on the cloud infrastructure and found out that through a lot of experimentation and measuring and using tools, what is the best setup in AWS cloud infrastructure that would yield the results I want in order to scale. And then when all said and was done, people were happy about it. I was personally happy about it. And then a few days later, I went in and looked at the code, which I honestly thought was top-notch, high performance. And then I just realized that I should just probably test the code. I should have done that from the beginning, because I then discovered that the issue was with one regular expression. And I suppose if you're long enough, you definitely have to make mistakes in order to learn, especially regular expressions. Anyway, so I fixed the issue, which was down to a specific regular expression that didn't quite work well. It didn't quite work for a specific pattern I was trying to match. And then suddenly the performance was a lot faster, like blazingly faster, like 5x faster. So 80% of what I wanted accomplished was actually focusing on algorithm performance rather than AWS infrastructure, which focusing on both is great. But I'd say that the first place you want to start with when looking at performance could probably be algorithm performance. So let's dive in. I'm just going to show you how to measure your algorithm performance using the project I built. So we're going to go to this project called Structura. This is the project I built. You could actually just clone the project to get started, or actually this is set up as a public template. So that means when you're creating a new repository, you could actually target this project in order to basically clone on the spot and basically pull in all the commits from this project into yours and just get a head start like that. So I'm using a Chrome laptop. It's very budget friendly, but it's not great for running code. So I tend to use code spaces, and basically it's it's great to work with. So basically your code is executing in the cloud essentially, and any laptop will do the job because you're just working on the project. So I'm just waiting for a little while for this thing to load. But essentially, Structura is a project that will let you, run your algorithm and figure out how fast is it, if it's fast at all. And basically, if you come up with a different version that you want to try out, you can compare both of them to figure out which one is the better. So one important thing to consider is that performance is very context sensitive, right? So I'm just going to start by saying that this project was built on a Node version 22. You can go into the dev container. So basically, I'm probably going to gloss over some details here if you know about code spaces, but basically the dev container basically details what is the environment that you're going to be running your code on. So I happen to let's see, be targeting this bit, TypeScript node 22. What's cool about node 22 is that it has experimental support for TypeScript. So I don't need any precompiler TypeScript or anything like that, right? So first advice is that if you're going to use this project, first figure out if you're running node on node, right? What is the node version that you're using? And maybe just figure out the image that actually you need to use to closely match or mimic your current environment, because that's extremely important, because you will get different results and performance based on different environments. And it's critical that you do. If you're running tests with the wrong environment, you'll probably make decisions with the wrong data, and you do not want that, right? So, all right, so let me give you a quick tour, right? So there's the README, right? This project comes with 2 files under the source folder. They could actually be named anything. Just for, references purposes, we're calling one stable and experiment. So when you clone it, you'll have these 2 files. Technically, it could be named anything you'd like. So what's the idea between stable and experiment? Well, it's just like the scientific method, right? You have a control group and the experiment, right? So a stable would probably be used for what you're currently using, and maybe you're trying to improve, or something that works best. An experiment is a different version of the stable algorithm that you're hoping that it will be faster, right? And then you test your assumptions by running performance tests. And then, if you're happy with that, you promote it to be the stable version and keep it iterating over and over, right? So this project also comes in with a nice utility, which it will help you generate randomized data, JSON data, for your needs. I won't go into it. You can read more about it in the README if you're into it. Okay, so let me just show you what we're going to be doing, right? Also, one thing, right, so around performance, there's different things that you want to measure. You could measure the performance, could be, sometimes it's often referred to how fast something is, but also you could be thinking of how economical it is in terms of memory usage, right? So for calculating how fast it is basically very simple. It takes in, what it works under the hood, it takes in a timestamp before you do the thing, and then a timestamp after you do the thing, and then you take the difference. And when you repeat it over and over for many iterations, you can figure out what's the average. Having an average is important because there's some variability in terms of performance every time that you run some code. So the larger the data set of results that you can average, the better idea of how it would perform normally, right? Right. The other one is peak memory usage, and that's a little bit more complicated because memory usage is kind of on a continuum, right? So different stages of your code, basically you're using maybe more or less memory. So what we're doing in this project is that there's something called sampling interval that every so often it will take a sample, just take a snapshot of how much memory you're using, right? And then basically it will take the maximum amount to determine what's your peak memory usage, right? And that serves you well for environments that are very constrained in terms of memory usage. All right, so that being said, well, we have this algorithm here. What this algorithm does is basically flatten a object. So we may have a deeply nested object, right? And what we're doing is basically putting all the properties into 0 depth, right? So curly braces and all the things are there, rather than having to iterate into an object deeply, right? You can use npm run measure to measure the performance of your algorithm. What will happen then is that this is going to be executed X amount of times, and the input data it's going to be supplied for you. So you don't have to think about that. You just have to. Your only concern now is to focus on writing the best algorithm that you can possibly write, right? So you can pass in arguments. I've just tried to doing it through the CLI, and I've made some mistakes. So there's another way to tell basically this mini framework what it is that you're trying to target, right? So you're going to go to this thing called measure RC, right? Here it says that the algorithm path is experiment. We're going to change that to be stable because we're looking at the stable thing at the moment, right? And then we're going to measure time and memory. Iterations, 100 is not nearly enough. Let's make it 100,000 by adding 3 zeros. The precision is in relation to, most of the stuff is measured in milliseconds, right? So precision 0, it will round out to the first whole millisecond, right? So precision here, basically, you just want to see the next 4 significant digits after the decimal point. This is especially, you want to have high precision when it's an algorithm that's extremely fast and normally would perform in, sub-milliseconds, right? Sampling interval is basically what I discussed earlier, where we're taking a sample of the memory usage. And the data type, do you know what? Again, there's different data types that are built in out of the box. I'm just going to select complex, right? Meaning it's complex data, right? JSON objects, right? Okay, so we're about to run this. Just a key thing to note, if the data hasn't been generated for you, it will do it for you before running the script. So let's just give this a try, right? There you go. So it says here, now we have results, right? So measuring performance, execution, duration, time in milliseconds, and peak memory usage, right? Here are the things that we defined: sampling interval, data type, precision, iterations, 100,000, right? So we went ahead and did that, and here are the results. Peak memory usage was 14 megabytes, and you can go in here to find your summary report. Also, you can check here, iterations, total duration, average, and that's all really neat, right? So this is basically, with this, basically you have an idea how your algorithm performs. Now, let's take a different thing, right? So we're just going to check experiment for a second, right? Experiment does the same thing in a different way, right? And we're hoping that experiment will be faster than stable. Here's hoping, but we first have to prove that is the case, right? So for that, we can go to compare RC, right? And we're saying that the algorithm path is stable and the algorithm path B is experiment. So we'll be comparing both. Stable is going to be on the left, the results on stable is going to be on the left, the results on experiment are going to be on the right. And we basically have the same setup, 100,000 iterations, which, by the way, it's the maximum. At some point, I'm going to try to figure out how to make it for you to be able to run more iterations at a time, but that's a limit that you should be aware of. I'll fix it or enhance it later. Yeah, complex data, right? So we're going to run the other command. Let me start a clean terminal here. And then we're going to run npm run compare instead. Right? It's going to do its thing. So basically, it executes all these operations in parallel under the hood, and then we get some results, right? So here you have it, right? Algorithm A is stable. Algorithm B is experiment, right? So this is stable and this is experiment. You see that the total time on the stable is larger than the one in experiment, and the average execution, and look at how quick this is, yet we've found a way to improve it for, what is that, maybe roughly 20%. So if you're doing this for every sort of algorithm that you write, especially if it's critical or more complex, these sort of performance gains will stack up, right? We can run it again just to improve it. You can tell that they're roughly taking the same amount of memory, and that's fine if you're not optimizing for memory. I don't know, and depends on your constraint project requirements and constraints, right? Environment constraints. So if I run that again, let's see if it was just a fluke or not. So it's doing its thing again. And then we see that, yeah, for 100,000 iterations, experiment is consistently better than stable in terms of speed. Okay. So I suppose that's a wrap up. Hopefully you found this type of content useful. If you have, just give me a thumbs up, a like, or a share. It really means a lot to me. I'm only starting out. This is the very first video covering a technical show and tell. If you have any specific questions about the project and you're on LinkedIn, well, you know how to reach me. If it's in any other platform, I'll be sure to put in a link and you can definitely reach out to me from there. All right. Catch you in the next time. Bye.